In order to use math to solve problems, we often have to interpret English words and phrases into a mathematical form. And we want to look at that now as an introduction to word problems. Addition is implied when these words and word phrases are used. The notion of more than implies addition. 5 more than x means 5 plus x or x plus 5. So 5 plus x or x plus 5. The sum, the word sum, you know, is the answer in an addition problem. So the sum of w and 3 means to add w and 3. Total refers to the addition of some items. The total of 6 and z would be 6 plus z. And increased by implies the notion of addition. So x increased by 7 means take x and add 7. Subtraction is implied with these words and phrases, but the trick with subtraction is this, and one key element in the interpretation process is that the order of the items is really important when we subtract. You know, with addition it's not so important because we have this commutative property of addition. We can change the order of the things which are added, but you can't change the order of things which are subtracted and get the same result. So the order is important here. 5 less than y. 5 less than, 5 smaller than y. Now, a lot of times when these words and word phrases are used and we know what operation to perform, we get confused, or we just think about writing the items under that operation in the order that we see them. We might think that this should be 5 minus y. But 5 less than y means 5 smaller than something that we presumably already have. So if we have y and we want 5 less than that, you see, it's take what we have and subtract 5. Very important idea. The difference between, now this isn't too hard, the difference between one thing and another means, now difference is the answer in a subtraction problem, and when the difference between is used, we take the first item after this word phrase and subtract the second one. So it's just w minus 3. So that's not a big deal. Okay, 8 decreased by a, decreased by. You see, it means we have this and we're going to decrease it by a. So it is 8 minus a. Now the only tricky one in the group is this 5 less than y. 5 smaller than the y that we already have. That's kind of a good way to look at it. Multiplication is implied by these words and phrases. Times implies multiplication. 3 times c means 3c like this, or I could put a times sign in between, but writing a number next to a letter implies multiplication. So I can just leave it like that, and it says to multiply. The product is the answer in a multiplication problem, so the product of one number and another means to multiply those two numbers. So the product of 4 and t means 4 times t, or simply 4t. 2/3 of v. Now, of often implies multiplication. So 2/3 of v means 2/3 times v, like this. Twice d. Twice something means 2 times whatever that is. So twice d means 2 times d. Division is implied with these words and phrases. N divided by 3. N divided by 3. Now, we have seen many times that fractions imply division problems, and we write the fraction that's implied here. Now that's one way to interpret. We could use the division symbol if we want to, but it's commonly the case that it'll be more useful if we write this in a fractional form. N divided by 3. N divided by 3, which means the same thing as n divided by 3 like this, but this may be more useful. Let's slide back over here. The quotient of, well, quotient is the answer in a division problem. So the quotient of a couple of items tells us that we're going to divide, and we're going to take the first item and divide by the second item. So the order is important here, but when the quotient of, when that phrase is used, we take the first item and put into the numerator and the second item and put into the denominator. So it's z divided by 4 is implied. the ratio of a couple of items. Same idea with quotient. The ratio of implies a fraction, and the first item following this phrase is in the numerator, and the second item is in the denominator. So this is S over 6. Let's interpret a few English expressions into mathematical form. It says the quotient of. Now, as soon as we see the word quotient, we know we have a division problem, and that the two items involved in the division follow this phrase of the quotient of, and it's the quotient of numerator and denominator. So let's look for that. The quotient of n and, well, we know right there that n is in the numerator, and whatever follows and is in the denominator. Let's see what it is. The quotient of n and, the sum of, so all of this then is going to be in the denominator. The sum of n and 6. That's n plus 6. You see, so we're kind of putting some things together, and it's important how we kind of look at this. The quotient of means fraction. And the first item following these three words, n, you see the part that is between this and, that rascal is in the numerator. And the part that follows the and goes into the denominator. So that's the idea. Here's another one, very similar. The sum of, now we're going to add something and something else. We can stop right there and we can write 5 plus. All right, the sum of 5 and what else? 5 and the product of, you see, 4 and n. Well, all of this, the product of 4 and n, is the other item being added in this sum. You see, the sum of one thing and all of that. Now, the other item that we're adding is the product of 4 and n. So that would be 4n. 5 plus 4n. Here's another. The product of, we're going to multiply. 3 and, that means 3 times. 3 times what? 3 and, now all of the rest of this is the other factor in that product. 3 and the difference between z and 4. Wow, okay, so we want the other part, the other item being multiplied is all of this. Difference between z and 4. Now we remember difference is the answer in a subtraction problem, and it's the first item following difference between. That's this minus that. Oh, so it's times, and I better open a parenthesis because I have two items here, you see, to write in the parenthesis. So it's z minus 4. So it's like that. The quotient of division. The quotient of 5, that's the numerator. And, now all of this is the denominator of that fraction. The product of 7 and x. There we go. Now sometimes we have to introduce the variable. On all of these, the variable was given in the phrase, but a lot of times the variable is something that we can come up with. For example, the difference between 7 and twice a number. Now this a number business, that just tells us that we don't know what the number is. We're going to need to let a letter stand in for it. Now I can put an X right in here if I want to, or an N or a C or a W, whatever letter I'd like. But a letter is in this position, and everything else is pretty much the same in this interpretation process. The difference between, all right, as soon as we see that, we know we're going to have to subtraction. And it's the difference between one thing and another, and our minus sign goes in that position. The difference between 7 and twice a number. Twice a number is 2 times a number, and the number is being represented by us. And if I let x stand for the number, then it would be, let's see, twice a number, 2x. The total of means we're going to add the total of a number and a number. What is it? We don't know. Let a letter stand for it. I'll let that number be n in this case. So n, total of n and the square of the number. Whoa, the square of the number. Well, the number is n. The square of the number would be, that's n squared. So this is the total of n and the square of n. All right, here's one more. The product of means we're going to multiply the product of a number and, stop right there, a number, let's let a letter stand for it, let's call the letter C this time. The product of C and, well, the and, although the word and is used, we know that product means multiply. So we're going to multiply one thing and another, or one thing times another, and it's C times something else. I'll open a parenthesis to show the multiplication. The product of a number and 1/2 of the number. Half of this number is 1/2 C. Now there is another way, by the way, to show 1/2 of the number. This is 1/2 of the number, but I could show it like this. Now, think of just a simple manipulation of 1/2 times C. Think of C as being C over 1. 1 times C is C. 2 times 1 is 2. So 1/2 times C written like this means the same thing as C divided by 2. You see, multiplying by 1/2 or dividing by 2 mean exactly the same thing. So we can represent it either way.